Welcome to the Drowsy Science channel, and hello. Thank you so much for being here. It might have been a long day, or perhaps, rather than counting sheep, you prefer to drift off to sleep with thoughts of far-off planets and wandering moons. In any case, the trip is for you tonight. Right now, all you have to do is relax. Allow your breathing to slow, your thoughts to become more gentle, and your body to become lighter, as though gravity had relaxed and you were now floating silently through space. Because we will be slowly drifting across the solar system tonight. From dusty rings and sun-licked worlds to shadowed craters and frozen oceans beneath the ice, they move in gentle spirals rather than in a straight line. A tale recounted using skewed axes, moons that sparkle in the dark, and magnetic storms rather than numerals. Every orbit has something unique and lovely to offer, from sideways worlds and diamond rains to ancient sunshine still gliding across the emptiness. We'll go cautiously, one drowsy fact at a time. Before we start, please think about softly hitting the like button and subscribing to the channel if these calm excursions help you relax or provide you with a nice way to conclude your day. One drowsy soul at a time, it guides others to this place as well. Let's get started. The winds of Neptune surpass the speed of sound. Neptune has the solar system's fastest winds despite being the planet that is furthest from the Sun. These winds surpass the speed of sound on Earth, whipping across its upper atmosphere at around 2,000 kilometers per hour. That's around 5 times what a commercial jet can do. The planet's interior heat, which radiates outward even while the surface is frozen, is probably the source of the wind's energy. Massive storm systems are carved into the pale blue clouds of Neptune by the winds, and the atmosphere is primarily made up of hydrogen, helium, and methane. The world is frozen and moving at supersonic speed all the time. There is a continent-sized chasm on Mars. The greatest canyon system in the solar system is Valles Marineris, which stretches over 4,000 kilometers across the Martian equator. It would cover all of the continental United States' width. It plunges more than 7 kilometers deep in some spots, which is more than 5 times deeper than the Grand Canyon. Scientists think that erosion, volcanic activity, and tectonic straining all contributed to its formation. Those may have formed as the planet's crust fractured and tore apart, in contrast to the canyons on Earth, which are usually sculpted by rivers. The scar on the surface of Mars suggests that there was a catastrophic geological past that is now fixed in time. There is no magnetic field on Venus. Venus is comparable to Earth in terms of size, mass, and composition, but it is devoid of a global magnetic field, which is an essential planetary attribute. Molten iron in the Earth's outer core moves to create a magnetic barrier that shields the planet from solar radiation. On the other hand, Venus appears to have a slow, or perhaps solid core, which might inhibit the type of dynamo effect required to generate a field. In the absence of this shield, the solar wind continuously attacks Venus's atmosphere, gradually removing lighter components. The lack of a magnetic field contributes to the explanation of Venus's transformation from a potentially Earth-like planet to a furnace world. Neptune and Uranus might receive diamond rain. It's possible that the severe conditions found deep within Uranus's and Neptune's atmospheres could produce something amazing. Diamonds falling. Thick layers of methane gas cover these icy giants. Additionally, experts think that methane can disintegrate and release carbon atoms when subjected to extreme heat and pressure. Tiny diamonds are created as these carbon atoms compress into crystalline shapes and fall toward the core. This process has been replicated in lab studies, demonstrating how hydrocarbons can condense into diamonds under the correct circumstances. Storms of glistening crystals could float through the deep blue blackness of far-off gas giants, if this notion is accurate. The only planet with plate tectonics is Earth. Earth's plate tectonics system is one of its most unique and life-supporting characteristics. A dynamic phototope of the mantle made up of moving crustal plates. Over geologic time, these shifting plates control the climate by recycling carbon dioxide, forming mountains, and causing earthquakes. No other planet has yet to provide unambiguous proof of this procedure. Despite having volcanic features and surface fissures, Mars and Venus seem geologically stationary in contrast. Because it drives the long-term cycles that maintain oceans, moderate temperature, and allow continents to shift over eons, plate tectonics may contribute to the habitability of Earth. A few asteroids have moons of their own. Although we tend to think of asteroids as lone wolves, some of them do have moons, which are smaller entities that orbit them. These little satellites are typically co-formed companions or captured pieces. In 1993, the Galileo probe discovered Dactyl, the first asteroid moon ever found, orbiting the asteroid RED. Numerous additional asteroid moon systems have since been discovered, some of which have several moons or odd binary configurations in which two asteroids orbit one another. These tiny systems demonstrate how gravity can bind even the tiniest items into silent, floating partnerships, even in the immensity of space. Mercury lacks a genuine atmosphere and instead features a ghostly exosphere. Mercury lacks a dense atmosphere to trap heat or disperse light, in contrast to Earth. Instead, atoms bounce around in a near vacuum called the exosphere, which is a tiny, tenuous shell of particles. Atoms such as sodium, potassium, and oxygen that have been blasted from the surface by solar wind and micrometeoroid collisions make up this exosphere. These particles continuously escape into space and are regenerated from the surface of Mercury, since the planet lacks the gravity necessary to support a true atmosphere. The end effect is a spectral, shimmering envelope of dispersed atoms that is not apparent to the naked eye, but can be found with the correct tools. Every second, millions of tons of mass are lost from the Sun. The Sun uses nuclear fusion to produce energy from more than 4 million tons of its own mass per second. Our solar system is powered by the light and heat released when hydrogen atoms combine to form helium in its core. This energy drives winds, warms planets, and supports life on Earth as it radiates outward in all directions. Even though the loss is negligible in relation to the Sun's mass, it accumulates over billions of years. The Sun will eventually run out of hydrogen fuel and start to transform. But for the time being, it keeps burning continuously, giving up a small portion of itself every second. The rings of Saturn are gradually vanishing. Saturn is surrounded by lovely rings, but they are temporary. Gravity is pulling them in, and Saturn's magnetic field is pulling them down as they slowly descend toward the planet. Over time, streams of ice particles and charged material flow inward during this process, which is called ring rain. According to Cassini spacecraft observations, the rings might be young by planetary standards, less than 100 million years old, and might completely disappear in a few 100 million years. Despite their seeming permanence, Saturn's rings are a transient phenomenon, a glittering show that will eventually be forgotten. Dust storms engulf the entire planet Mars. The rusty, desert-like terrain of Mars and the enormous dust storms that can cover the entire planet are its most well-known features. These storms can reshape the surface and block out sunlight for weeks or even months. A hazy reddish glow is produced by the extremely thin particles, which can remain suspended in the atmosphere. Some storms start out as little gusts, but can quickly intensify because of feedback loops between geography, wind, and heat. A similar storm in 2018 caused the Opportunity rover's solar panels to get suffocated with dust, ending the rover's mission. Mars is nevertheless a dynamic and restless planet, despite not having any oceans or rain. Under its ice, Europa might contain a salty ocean. There is compelling evidence of a massive subterranean ocean of liquid water beneath the icy surface of Europa, Jupiter's moon. The interior of Europa is flexed by tidal pressures from Jupiter's gravity, producing heat that could prevent the water from freezing solid. Spacecraft have found magnetic signatures and chemical residues that confirm the ocean idea, and the surface is speckled with dark lines and ridges, which are indications of changing ice. The potential for life to exist in this secret water is what makes Europa so intriguing. It is a dark, foreign ocean that may be rich in biological elements, but it is also locked under ice and warmed from below. There is a volcano on Mars that is higher than Everest. About 3 times the height of Mount Everest, Olympus Mons is the tallest volcano in the solar system, rising about 22 kilometers above the Martian plains. It would span the whole state of New Mexico because it is that wide. Because Mars lacks plate tectonics, the Olympus Mons, which was formed by several eruptions over millions of years, expanded to such a great size. Volcanic hotspots on Earth change over time, forming island chains like Hawaii. On Mars, however, the crust doesn't move. Therefore, magma can repeatedly erupt in the same location. As a result, there is only one enormous shield volcano that silently looms in the Martian night. The rings of Saturn are quite thin. Despite being almost 280,000 kilometers across, Saturn's magnificent rings are remarkably thin. The rings are often less than 100 meters thick. Compared to many city buildings, that is thinner. The ring particles, which are primarily composed of water ice, vary in size from dust grains to boulders the size of houses. They almost vanish from view like a sideways tilted sheet of glass as sunlight passes through the ring zone. The planet's gravity, the self-organization of billions of ice shards, and the effect of tiny shepherd moons all contribute to their continued flatness. They look solid from a distance, but they are fragile and ethereal up close. The densest planet is Earth. Earth has the highest density of any planet in the solar system. This indicates that because of its metal-rich core and silica-rich mantle, it has more mass per volume than any other planet. Despite Jupiter's much larger size, Earth has a density of roughly 5.5 grams per cubic centimeter, which is higher than Jupiter's. The velocity of molten iron in the Earth's outer core produces the magnetic field, and this high density is a major contributor to this motion. The dense, hefty, and layered core structure of our planet shapes not only its gravity, but also its geology and space protection. Like a musical instrument, the sun vibrates. The sun is always ringing with pressure waves that reverberate through its burning layers, yet we are unable to hear them. Ultra-low frequency sounds that are far below human hearing are produced by these oscillations, which are brought on by rising and falling plasma currents. Scientists use a method known as helioseismology to investigate these vibrations. Similar to how geologists use seismic waves to investigate the inside of the Earth, researchers can map the internal structure of the Sun by monitoring how the waves move and bounce within its body. Deep within the core, these solar songs disclose magnetic activity, secret fluxes, and fusion dynamics. In a way, the Sun is constantly humming, subtly, and using rhythm and vibration to disclose its secrets. Venus makes a retrograde rotation. Venus exhibits retrograde rotation, which is the opposite direction of rotation of most other planets in the solar system. The Sun rises and sets in the west and east, respectively, on Venus. Its extremely sluggish rotation makes it even stranger. On Venus, a day lasts longer than a year. A full rotation takes 243 Earth days. Although scientists are unsure of the exact cause, a big collision early in its existence that changed its spin is one option. According to a different idea, the Sun's axis was gradually flipped over time via tidal forces. Regardless of the reason, Venus is a lone planet with a sluggish rotation and an inverted rhythm. There are over 90 moons orbiting Jupiter. Jupiter, a gas giant, is more than just the biggest planet. In addition, it is the Moon's king. There are currently more than 90 natural satellites orbiting it that astronomers have detected, and more are being found. The Galilean moons, so named in honor of Galileo Galilei, who made the first observation of them in 1610, are its four largest moons: Io, Europa, Ganymede, and Callisto. A plethora of smaller, irregular moons, many of which were grabbed from passing objects, can be found beyond these giants. Some are only a few kilometers broad, while others orbit backward. They orbit Jupiter together, forming a miniature solar system, constrained by the history and tremendous gravity of the planet. Ice is concealed by Mercury's shadows. It is frigid at night and scorching during the day. You wouldn't expect to see ice on Mercury, but it's there. Temperatures are still frigid enough for water ice to form at its poles, deep within craters that are never exposed to sunlight. For millions of years, ice has been preserved in these constantly shaded areas, which function as natural freezers. The existence of these brilliant icy patches has been verified by radar reflections from spacecraft such as Messenger. According to scientists, the water might have come from previous volcanic eruptions or comet impacts. Ice endures in the midst of one of the hottest worlds, trapped in darkness and protected from the unrelenting sunfire by crater walls. There might be an ocean in Pluto's heart. Sputnik Planitia, a luminous heart-shaped structure on Pluto, is more than simply a picturesque sight. It might be the outward manifestation of a huge subterranean ocean. Evidence from the New Horizons probe indicates that Pluto may have a layer of liquid water beneath its ice shell, despite the planet's distance from the Sun and cold enough temperatures to freeze nitrogen. The apparent geological activity and the weight of the Harapid Basin suggest a slushy, convecting subsurface. If this ocean is real, the heat from radioactive decay and the insulating ice layers above it may keep it liquid. There may be a hidden sea that silently endures even in the icy regions outside of Neptune. The majority of the asteroid belt is empty space. Contrary to common belief, flying through the asteroid belt would not resemble avoiding boulders in a science fiction film. The belt is actually quite large and quite sparsely populated. It is home to millions of rocky things. However, they are separated by vast distances and are situated between Mars and Jupiter. An impediment would hardly ever be encountered by a spaceship passing past. Less than 5% of the Moon's mass is found in the whole asteroid belt. Most of that is due to its biggest members, such as Vesta and Sarah. The remainder are dispersed pieces of the early solar system, old building blocks that didn't come together to form a planet. Uranus rotates in relation to the Sun. The majority of dams tilt slightly on their axis and spin like tops. However, Uranus is so far over that it has an axial tilt of 98 degrees, effectively rolling along its orbital path. This gives it harsh and strange seasons because during some sections of its orbit, its poles point nearly directly at the Sun. There are 42 years of daylight and 42 years of darkness for each pole. Although the exact source of this tilt is still up for question, it might have been sideways thrown by a huge collision a long time ago. Uranus has one of the most peculiar climates in the solar system due to its slanted orientation. The radiation belts of Jupiter are lethal. The strongest magnetic field of all the planets surrounds Jupiter. Additionally, it has radiation bands so powerful that they would destroy our spacecraft if left unprotected. Similar to Earth's Van Allen belts, but far more potent. These belts are made up of charged particles that have been trapped by the planet's magnetic field, creating zones of high-energy radiation. The biggest moons of Jupiter are also subject to this radiation, which may have an impact on their surfaces and habitability. Spacecraft must remain in LA radiation routes or take additional shielding precautions in order to survive in orbit around Jupiter. The world is lovely, but it is also fraught with unseen peril. Almost all of the solar system's mass is found in the Sun. The Sun, which is the center of our solar system, rules not only with light and gravity, but also with sheer mass. It can accommodate more than 99.8% of the solar system's total mass. This implies that less than 0.25% is made up of all other objects, including planets, moons, asteroids, comets, and dust. Everything in orbit, from far-off comets in the Oort cloud to minuscule grains in the asteroid belt, is bound by its gravitational pull. The fusion events at its center are powered by this enormous mass, which transforms hydrogen into helium and fills space with daytime energy. Compared to classical planets, dwarf planets are more prevalent. There is a dispersed population of frozen, far-off objects beyond Neptune, several of which are big enough to be considered dwarf planets. Although Pluto is the most well-known, there are others. This status is shared by others such as Eris, Almia, and Makemake, and new candidates are continually being found in the Kuiper Belt and beyond. The 8 classical planets may really be greatly outnumbered by the number of dwarf planets. These tiny, spherical worlds are unspoiled, ancient remnants of the early solar system. Despite orbiting in the frigid shadows, they contain hints about how everything we know came to be. On Venus, a day is longer than a year. Of all the planets, Venus has one of the slowest revolutions. Once on its axis, it rotates in 243 Earth days. At the same time, a single orbit of the Sun takes only 225 days. Accordingly, a day on Venus, measured from dawn to sunset, is longer than a year. Extreme surface conditions with temperatures high enough to melt lead are also a result of this slow rotation. Venus is a realm of sluggish, simmering heat and spooky, sunless days, especially when combined with its thick, acidic atmosphere and crushing pressure. Methane lakes can be found on Titan. The only other known location in the solar system with stable liquids on its surface that aren't composed of water is Titan, Saturn's biggest moon. Rather, Titan's rivers and lakes are made of liquid ethane and methane that flow over a terrain shaped by cold chemistry. Seasonal storms and methane rain are among the weather systems created by its dense, nitrogen-rich atmosphere. There are some enormous lakes on Titan that are hundreds of kilometers long. Scientists think there might be an underground ocean of water underneath the frozen top. Titan is a planet having recognizable features, such as rivers, clouds, and coastlines made of strange materials. It's possible that Mars's moons are captured asteroids. Phobos and Deimos are the 2 small, malformed moons of Mars. They resemble asteroids more than typical moons because they are stony, irregular, and crater-pocked. Many scientists think they were formerly in the asteroid belt and were long ago caught in the gravitational pull of Mars. This is supported by their odd orbits and low density. However, some other hypotheses speculate that they might have formed from debris following a significant impact. Phobos will eventually fragment or collide with Mars as it steadily spirals toward the planet. Deimos is fading off. Relics of a turbulent history, these tiny moons are silent travelers in orbit. Jupiter's heat causes it to shine. Jupiter emits more energy than it takes in from the Sun, in contrast to most other planets. Remaining heat from the planet's birth, a kind of gravitational energy released as its massive mass compressed together, is the source of this interior glow. It keeps contracting a little over time, producing heat in the process. Jupiter's erratic weather systems, which include its massive storms and whirling bands, are caused by this warmth. Beneath layers of clouds, Jupiter gleams in the infrared spectrum like a blazing coal. It nearly turned into a star, but it's not one. It might have ignited into a failing sun if it had been somewhat larger. Math led to the discovery of Neptune. Neptune was not found by merely using a telescope, in contrast to other planets. Rather, scientists saw minute variations in Uranus's orbit that were inexplicable given current gravity. These odd movements were exploited by two mathematicians working separately in the 1840s to determine the location of a secret planet. Neptune was visible when astronomers aimed their telescopes at the determined location. It was a victory for celestial mechanics, proving that mathematical mapping was sufficient to map invisible forces. Before it could be seen through glass, Neptune was the first planet to be discovered on paper. Numbers help to illuminate this realm. There is a hexagon on Saturn's north pole. A gigantic cloud structure in the shape of an almost flawless hexagon rotates at Saturn's north pole. Wider than Earth, this six-sided jet stream is more than 30,000 kilometers across and has lasted for decades or even centuries. According to scientists, the hexagon is formed by the interaction between steady air waves confined near the pole and Saturn's rotating atmosphere. When fluids are rotated at varying speeds in laboratory studies, similar forms emerge. One of the solar system's more exquisite and fantastical phenomena is the ability of such a geometric shape to spontaneously arise in a planetary atmosphere. The atmosphere of the Sun is hotter than the surface. Although it may seem obvious, the Sun's surface is not the hottest portion of the planet. The temperature of the photosphere, or visible surface, is roughly 5,500 degrees. The corona, the outer atmosphere, however, has a temperature of over 1,000,000 degrees. For decades, experts have been perplexed by this sudden rise in temperature. According to one idea, the corona is heated from below by magnetic waves that go upward from deep within the Sun. Nanoflares, which are tiny sun explosions, are another option. In any case, the Sun's outer layers radiate enigmatic intense heat that extends much beyond their origin. There are many cold worlds in the Kuiper Belt. The Kuiper Belt is a broad ring of icy objects located beyond Neptune. Numerous frozen bodies, including Pluto, Eris, Haumea, and Makemake, can be found there, and it is billions of kilometers away from the Sun. These are old relics from the birth of the solar system, not stars or planets. While some are uneven and tumble through space, others are spherical and are categorized as dwarf planets. Although it is much colder and includes more primordial ice, the Kuiper Belt shares structural similarities with the asteroid belt. It is a frozen archive of the materials used to construct the outer planets, known as a fossil zone. The distance between the Sun and the Oort cloud might be a light year. A fictitious shell of frozen bodies, known as the Oort cloud, is located far beyond the Kuiper Belt, even farther away than Pluto can reach. This enormous orb of frozen debris is believed to encircle the solar system and stretch almost a light year away, despite never having been directly witnessed. It is most likely the cause of long-period comets with erratic orbits that emerge from the depths of space. Due to their tenuous bond with the Sun, these far-off objects could be sent rushing inward by a passing star or galactic tide. The Oort cloud, a far-off halo of icy nomads, indicates the actual boundary of the Sun's gravitational pull, if it exists. The solar system's most volcanic world is Io. Io, the moon of Jupiter, is a raging, restless planet with numerous active volcanoes. Eruptions of molten rock and sulfur continuously change its surface, illuminating the surrounding area in striking shades of red, black, and yellow. Volcanic plumes can reach heights of hundreds of kilometers. Tidal heating is the cause of this intense activity. Along with gravitational pulls from nearby moons, Jupiter's gravity squeezes and stretches Io. Its violent geology is powered by the friction created by this continuous flexing, which heats the inside. The surface of Io, a lava-lit moon with a molten heart, is youthful, erratic, and constantly changing in contrast to Earth's cold crust. Triton circles Neptune in reverse. The largest moon of Neptune, Triton, is distinct from other large moons in that it revolves around its parent planet in the opposite direction of Neptune's rotation, a movement known as retrograde orbit. This rearward trajectory implies that Triton was probably grabbed from the Kuiper belt rather than forming with Neptune. Neptune's initial satellite system might have been disrupted by that capture, which could have produced severe upheaval. With cryovolcanoes that shoot ice particles into space and a thin atmosphere that fluctuates with the seasons, Triton is also a geologically active planet. Cold, far away, and in backward motion. In every way, the world of Triton defies expectations. The moon of Earth is exceptionally big. Earth's moon is massive in relation to its host planet. It is the largest satellite of any rocky planet in the solar system. The moon is actually around 1/4 of Earth's diameter, which is more common for dwarf planet-moon systems than for larger planets. According to the majority of scientists, the moon formed when a body the size of Mars collided with the early Earth, sending debris into orbit, where it finally came together to form the moon. Over billions of years, this intimate relationship has had a significant impact on Earth's stability, temperature, and tides. Our moon is more than just a friend. It is a cosmic legacy of planetary regeneration and collision. The orbits of planets are not perfectly round. The planets' orbits are actually ellipses, which are slightly stretched circles with the Sun off-center, despite the fact that we frequently see them traveling in perfect circles around the Sun. Because of its elliptical form, every planet has an aphelion, or point, that is the furthest from the Sun, and a perihelion, or point that is the closest. The difference is small for most planets, but more striking for some, such as Pluto and Mercury. Seasons, solar radiation, and orbital speed are all impacted by these changes. Johannes Kepler's 1600 description of the elliptical nature of planetary motion fundamentally altered our comprehension of the solar system's exquisite mechanics. The edge of interstellar space is where some comets originate. The Oort cloud, a far-off shell of frozen debris that may be located close to a light-year from the Sun, is thought to be the source of long-period comets, the type that only occur once every few thousand years. These comets have extended, loosely bound orbits and are frequently displaced from their resting positions by galactic tides or passing stars. They can flare up with amazing tails that are visible from Earth when they plunge inward toward the Sun. It's possible that some were pushed into motion after drifting in darkness for billions of years. Their dazzling returns are brief glimpses of the oldest unexplored stuff in the solar system. The Sun is going to turn into a white dwarf. Like all stars, the Sun has a limited lifespan. It will run out of hydrogen fuel in its core and grow into a red giant, swallowing up the inner planets at around 5 billion years. The remaining core will form a white dwarf, a compact remnant the size of Earth composed primarily of carbon and oxygen, after the outer layers are shed in a luminous shell of gas known as a planetary nebula. Over trillions of years, this white dwarf will gradually cool down and cease to generate energy. At the end of its celestial voyage, it will be our Sun's last form, a blazing ember in the night. Like Earth, Mars has seasons. Mars has seasons just like Earth, despite having a thinner atmosphere and a cooler climate. This is due to the fact that Mars's axial tilt is roughly 25 degrees, which is comparable to Earth's 23 degrees. Because of this tilt, sunlight strikes the hemispheres more directly at different periods of the year as it revolves around the Sun. A cycle of spring, summer, fall, and winter with fluctuating light and temperature is the end outcome. Dust storms, polar ice caps, and even minute variations in air pressure are all impacted by Martian seasons. However, because Mars takes almost twice as long to complete a year, they unfurl more slowly than on Earth. The largest moon in the solar system is Ganymede. Even larger than the planet Mercury, Jupiter's moon Ganymede is the solar system's largest natural satellite. With a circumference of more than 5,000 kilometers, Ganymede features a crust covered in frozen ice and old scars, a rocky core, and a potential subterranean ocean. It is the only moon known to possess a magnetic field of its own, which gives its thin atmosphere the ability to produce glistening auroras. According to scientists, Ganymede might have a complex interior world made up of several ocean levels encased in ice sheets. It orbits deep within Jupiter's magnetic field, quiet and dark despite its size and richness. At times, Pluto's orbit is nearer the Sun than Neptune's. Despite being the most distant of the dwarf or classical planets, Pluto occasionally passes closer to the Sun than Neptune due to its very irregular orbit. The last time Pluto was momentarily the 8th planet from the Sun, rather than the 9th, was between 1979 and 1999. Nevertheless, because their orbits are in resonance, the two worlds never clash or approach perilously. Pluto completes precisely 2 orbits for every 3 that Neptune completes. Their trajectories never overlap thanks to this gravitational choreography, which keeps them dancing steadily. Time and the rhythm of the heavens control this delicate equilibrium. Every 11 years, the Sun's magnetic field reverses. The magnetic field of the Sun rotates about every 11 Earth years. The magnetic poles in the north and south alternate positions. This process, called the solar magnetic cycle, influences solar activity such as sunspots, flares, and coronal mass ejections, and is linked to the Sun's core dynamics. The Sun is more active during solar maximum, when magnetic storms and radiation are at their strongest. Activity declines as the cycle wanes, ultimately leading to solar minimum. Satellites, the Earth's upper atmosphere, and even auroras are impacted by these cycles. The magnetism of the Sun fluctuates, pulsing and flowing like a magnetic heartbeat. Natural disasters are not caused by planetary alignments. There is a widespread misconception that earthquakes, floods, and other significant natural disasters can be caused by planetary alignments. However, there is no scientific proof of these effects. The Moon and the Sun have a much stronger gravitational pull than any other planet on Earth. Their total effect is insignificant, even at infrequent alignments. Compared to large but far-off planets like Jupiter or Saturn, the Moon's proximity has a much greater effect on tides and seismic stress. Although they are mathematically fascinating and beautiful, planetary alignments are not harmful due to gravity. Not a cosmic omen, but a hushed dance of far-off worlds. Decades pass before leaving the solar system. It's not easy to get away from the Sun's draw. The area beyond the heliopause gives way to the interstellar plasma medium, and spacecraft, such as Voyager 1 and 2, which were launched in the 1970s, have only lately entered interstellar space. It took these expeditions almost 40 years to get to that line, going more than 60,000 kilometers per hour outward. The Voyager spacecraft have traversed the planet's orbits, traversed the Kuiper belt, and proceeded into the night. They have a golden record with earthly sounds on it and instruments that are still in working order. They serve as our discreet emissaries around the galaxy. We are protected from space radiation by Earth's magnetic field. The movement of molten iron in the Earth's outer core creates an unseen magnetic field that envelops our globe. The atmosphere and surface are shielded from dangerous solar and cosmic radiation by this magnetic field, which deflects charged particles away from the Sun. Without it, our atmosphere would be steadily eroded by the solar wind, much as it probably was on Mars. Additionally, the field directs certain particles toward the poles, where they combine with molecules in the atmosphere to create auroras, which are glistening curtains of violet, red, and green light. Over geological time, the Earth's magnetosphere serves as a dynamic shield that is vital to maintaining life and the climate. The Moon is gradually separating from Earth. The Moon travels around 3 times a year, 8 centimeters away from the planet. Tidal interactions are the cause of this gradual retreat. The Moon was pushed slightly outward by the bulges in our planet's oceans caused by the gravitational attraction between Earth and the Moon. The Moon was much closer and seemed much bigger in the sky in the distant past. Our days progressively get longer as it moves away, and eclipses become less common and spectacular. The Moon's orbit will be so vast in billions of years that it will be impossible to witness a total solar eclipse. Even though we can't feel it yet, the sky is changing. Mirrored icy worlds can be found in the Kuiper belt. Beyond Neptune, the Kuiper belt is home to smaller icy worlds with remarkably brilliant surfaces in addition to dwarf planets. Halmi, a rapidly spinning football-shaped object covered in crystalline water ice, is one example. Another Eris is one of the solar system's most reflective bodies, reflecting almost all of the sunlight that strikes it, making it appear brighter than just fallen snow. It's possible that impacts, chemical reactions, or cryovolcanism brought these particles back to the surface. Some of these far-off worlds shine like icy mirrors in the darkness at the limit of the sun's reach, catching a sliver of sunshine in their frozen solitude. Water is sprayed into space by Enceladus. Enceladus, Saturn's little moon, conceals a magnificent secret. Through fissures called tiger stripes, towering geysers of ice crystals and water vapor shoot out into space from its south pole. Tidal heating under the surface, where friction from Saturn's gravitational pull maintains a subsurface ocean in a liquid state, is what drives these plumes. The plume's content raises the tantalizing potential of life by containing organic molecules, salts, and even evidence of hydrothermal activity. A live link between the Moon and planet is formed when some of the water escapes into space and contributes to the replenishment of Saturn's E-ring. Some asteroids are nothing more than debris heaps. Asteroids aren't always made of solid rock. Many are loose groups of dust, gravel and stones that are simply kept together by gravity. Constructions referred to as debris mounds. When impacts break up larger asteroids, the debris gradually reassembles to form these delicate entities. Large interior holes, odd spin patterns, and form changes under pressure are all possible characteristics of rubble pile asteroids. Such bodies have been visited by missions like Hayabusa 2 and OSIRIS-REx, demonstrating their permeable and sensitive nature. These asteroids are chaotic collections rather than solid remnants. The Sun is surrounded by ancient drifting remnants of early planetary building that are barely holding themselves together. The size of Mercury's core is out of proportion. Despite being a small planet, Mercury possesses an iron core that is exceptionally large. About 80% of the planet's radius is made up of this metallic core, which is a much higher percentage than that of Earth or Venus. It's still unclear why this core is so large. According to some scientists, a massive impact may have removed Mercury's dense rocky mantle. Others think it evolved near the Sun, where heavier materials accumulated more easily due to solar pressures. A metal-heavy survivor of the solar system's turbulent adolescence, the planet has a thin crust, a massive core, and a feeble magnetic field. There are no moons on Venus. Mercury and Venus are the only rocky planets without natural satellites. Venus's predicament is more mysterious, but Mercury's absence of moons may be explained by its closeness to the Sun. Venus has no moon, yet it is almost the same size as Earth, which has a big moon. According to some ideas, it might have formerly had a moon that was lost in a collision or plunged back into the planet. Others contend that stable orbits may not develop because of Venus's sluggish, retrograde revolution. Venus, a bright, cloud-covered world without a lunar companion in its twilight sky, revolves alone, whatever the reason. While Earth has only one moon and Mars has two small ones, the majority of solar systems have moons orbiting gas giants. The outer solar system's massive planets are encircled by extensive satellite systems. From enormous worlds like Ganymede and Titan to tiny captured asteroids, Jupiter and Saturn each have dozens of known moons. Numerous frozen moons, some with intricate orbits and secret oceans, are also found on Uranus and Neptune. Over time, satellites are coalescing, and debris is drawn in by the gravitational pull of these gas giants, which function similarly to miniature solar systems. There will be more moons the further you are from the Sun. A reminder that in the cold, gravity finds friends. Planets have been photographed by Hubble from Earth's orbit. The Hubble Space Telescope has taken precise pictures of the outer planets, such as cloud bands on Jupiter, storms on Neptune, and seasonal changes on Mars, despite orbiting only above Earth. In addition to spacecraft flybys, these photos offer long-term observations of planetary auroras, ring systems, and changing weather patterns. Scientists can study atmospheres in visible and ultraviolet light, observe storm development, and keep an eye on impact events thanks to Hubble's clarity. Hubble observes the changing faces of our nearby worlds as well as the far-off galaxies from its peaceful vantage point in low Earth orbit. The Great Red Spot on Jupiter is centuries old. A huge storm that could engulf 2 or perhaps 3 Earths is known as the Great Red Spot, and it is circling Jupiter's southern hemisphere. For at least 350 years, if not more, it has been raging. The storm, which was first seen using early telescopes in the 1600s, has evolved over time, becoming smaller but still strong. Complex chemical processes in Jupiter's atmosphere that are brought on by sunlight and substances found at high altitudes could be the source of its crimson color. On the outside, wind speeds surpass 400 kilometers per hour. This Jovian tempest remains imprisoned in the planet's tumultuous bands for decades, whereas Earth's storms last only a few days or weeks. More heat is emitted by Neptune than is received from the Sun. Neptune is not a frozen, inactive globe despite its distance from the Sun. Actually, it emits around 2.6 times as much energy as it gets. Strong winds and storm systems, including the fastest known winds in the solar system, are caused by this interior heat. Although the precise cause of Neptune's heat is still unknown, theories include radioactive decay in its core, sluggish gravitational contraction, and leftover energy from the planet's birth. Neptune is a place of unexpected vitality despite its great distance. A planet whose windswept atmosphere is always changing, with a chilly surface and a heated, restless interior. the only planet containing water in each of the three states is Earth. The fact that water is a solid, liquid, and gas on our planet's surface makes it special. Clouds and vapor circulate through the atmosphere, land and sea, ice caps and glaciers and lakes and oceans. Earth's distance from the Sun, atmospheric pressure, and comparatively constant temperature all influence this equilibrium, which is essential for life. Water may exist in solitary forms on other worlds. None exhibit the same dynamic planet-wide presence, though I do observe crusts, vapor in thin atmospheres, and buried underground oceans. Water flows, freezes, and evaporates on Earth in a never-ending dance that sustains life. The heliopause indicates where the Sun's influence ends. The thin gas and dust between stars, known as the interstellar medium, eventually collides with the solar wind as it moves away from the Sun. This border, known as the heliopause, delineates the outermost portion of the heliosphere, the Sun's protective bubble. After this, the solar wind is outweighed by the pressure from other stars and galactic particles. In 2012 and 2018, respectively, Voyager 1 and Voyager 2 passed the heliopause and entered actual interstellar space. The heliopause, the last burst of solar influence before deep space begins, signifies the end of the Sun's energy reach, even if its gravity still reaches considerably deeper. A local cloud is allowing the solar system to drift. The local interstellar cloud is an area of space through which our entire solar system is traveling. A thin, roughly 30 light-year-wide concentration of dust and gas. It is a component of the local bubble, a bigger structure created by old supernova explosions. The Sun's heliosphere functions as a screen to deflect interstellar material as it passes through this cloud at a speed of roughly 7,000 kilometers per hour. In order to comprehend how interstellar conditions can impact cosmic rays, the heliosphere's form, and even Earth's temperature, scientists investigate this cloud. We are not in space, sitting motionless. We are moving through a cosmic fog at a sluggish and quiet pace. There are moons with active geology. Planets are not the only places with activity. There are indications of surface alteration and internal energy on a number of the solar system's moons. There are numerous active volcanoes on Jupiter's moon Io that are fed by tidal heating. Water vapor plumes are released into space by Enceladus, which orbits Saturn. Internal heating probably stirs the subterranean waters on Europa and Ganymede. Cryovolcanism, or icy eruptions triggered by changing pressures below, is evident even on faraway Triton, Neptune's captured moon. Static ice balls are not these moons. Beneath their frozen exteriors, these restless worlds contain geology, chemistry, and possibly even the possibility of biology. The atmosphere of Pluto fluctuates. Pluto has a thin atmosphere made up primarily of nitrogen with traces of carbon monoxide and methane, despite its small size and frigid temperature. Pluto's eccentric orbit causes surface ices to sublimate into gas as it gets closer to the Sun, creating a hazy envelope that spreads out into space. However, the atmosphere cools and compresses as it gets farther away, returning to the surface as frost. Over Pluto's 248-year orbit, this cycle repeats. Pluto's atmosphere was visible as a thick blue haze during the 2015 New Horizons flyby, providing a brief respite for a planet that is primarily in deep cosmic winter. The center of the Sun is hotter than 15 million degrees. Temperatures rise to more than 15 million degrees Celsius deep below the Sun's core. In this process, a tremendous quantity of energy is released as hydrogen atoms are squeezed under extreme pressure until they fuse into helium. The heat and light from the Sun, as well as eventually all life on Earth, are powered by this fusion. It takes hundreds of thousands of years for the energy produced in the core to travel through layers of thick plasma and reach the surface. After escaping, it takes a little over 8 minutes to get to us over space. The sun's brilliant calm conceals a heart that is unfathomably hot and fierce. The ring system of Uranus is somewhat inclined. Uranus has rings, but Saturn's are the most recognizable. Although they are significantly fainter and darker, there are actually 13 known ones. These rings, which are composed of microscopic rock and ice fragments, revolve in accordance with Uranus's peculiar tilt. From above the North Pole of the Sun, the rings seem vertical because the planet is nearly on its side. Some of the rings have sharp edges and are narrow. They may have been sculpted by tiny moons that guide their construction. When they obscured a background star's light in 1977, they were finally found. A sideways planet is surrounded by faint, dark bands. The Sun creates a magnetic bubble known as the heliosphere. The Sun releases a stream of charged particles called the solar wind, which spreads outward in all directions and encircles the solar system in a huge magnetic bubble. This structure, known as the heliosphere, serves as a barrier against radiation from the galaxy. Enclosing the planets, comets, and other far-off objects, it extends well beyond Pluto and is shaped by solar activity and interstellar pressure. The heliopause is its outermost point, where solar impact diminishes. The heliosphere follows the Sun's orbit around the Milky Way, shielding the solar system as it passes through shifting interstellar space. Einstein's theory of gravity was supported by the orbit of Mercury. Astronomers had been noticing something odd about Mercury's orbit for centuries. Over time, its perihelion, its closest approach to the Sun, slowly changed more than Newtonian physics could explain. The answer came from Albert Einstein's general relativity theory in 1915. Relativity states that large objects, such as the Sun, distort spacetime, gradually changing the courses of planets. The tiny but detectable impact on Mercury's orbit was just what Einstein had predicted. It explained a peculiarity in the motion of a stony, burnt globe and constituted one of the earliest experimental confirmations of his groundbreaking hypothesis and mathematical success. Earth's tides are shaped by the Moon. The Moon's gravitational pull is primarily responsible for the daily rise and fall of ocean tides on Earth. The side facing the Moon and the side opposite it develop bulges as a result of the Moon's gravitational pull on Earth's oceans. These bulges travel across the world as the Earth rotates, causing high and low tides. Depending on how it aligns with the Moon, the Sun can also affect tides, producing spring and neap tides. In addition to influencing oceans, tidal forces have the ability to gently move the Earth's crust and even change the planet's rotation. The waters move because of the Moon's quiet pole. Beyond Neptune, there might be unexplored planets. Certain far-off objects in the Kuiper Belt have been observed by astronomers to have elongated, clustered orbits that are difficult for the known planets to account for. One popular notion is that the gravity of a massive, as yet undiscovered planet, sometimes referred to as Planet 9, may be affecting these far-off trajectories. This hidden planet, if it exists, would orbit well beyond Pluto, have a mass several times that of Earth, and take thousands of years to complete one revolution. Although there isn't any concrete proof yet, telescopes are looking. Our knowledge of the outer architecture of the solar system would change if it were discovered. There might be an ocean beneath Callisto's frozen surface. Callisto, the moon of Jupiter, has a cratered, peaceful surface that hasn't seen any recent geological action. However, Scientists believe there might be an ocean beneath that frozen crust that is maintained liquid by internal heating and possibly residual heat from formation. Galileo's satellite magnetic data suggested a conductive layer beneath the surface that would be consistent with salty water. If verified, Callisto would become another ocean world, joining Ganymede and Europa. Less well known is the possibility that the components for life could be found in Callisto's deep, dark sea, which is silently enclosed by time and ice. Despite being farther from the Sun, Venus is hotter than Mercury. Venus is the planet with the warmest surface temperatures, despite Mercury being the nearest to the Sun. This is because of its extraordinarily dense atmosphere, which is primarily made up of carbon dioxide and traps heat in an uncontrollably strong greenhouse effect. Venus's surface is hot enough to melt lead at over 460 degrees Celsius. In addition to reflecting sunlight, the thick clouds keep heat from escaping. Mercury, on the other hand, cools quickly on its dark side due to its thin exosphere, which lacks this insulation. Venus's intense heat is caused by more than just its closeness to the Sun. It has to do with atmosphere and trapped radiation power. Ice makes up the majority of Saturn's rings. Saturn's rings are made up of innumerable tiny particles, primarily water ice, that range in size from dust grains to house-sized chunks, despite their appearance as solid bands. Saturn's gravity and the influence of neighboring moons hold these frozen particles in place as they revolve in an extraordinarily thin, flat disk. When viewed from a distance, the rings are among the brightest features in the solar system because of the ice's exceptional reflectivity. Narrow spaces, wave patterns, and ringlets formed by gravitational resonances are embedded inside the rings. Sculpted ice in motion, the rings are dynamic, ever-changing creations. Ceres is a minor planet as well as an asteroid. Ceres is the largest object in the band of asteroid belts between Mars and Jupiter. It is so big that it is considered a dwarf planet. Unlike smaller asteroids, Ceres is spherical and may have a layer of mud or briny water beneath the surface. It was discovered in 1801. Unusual bright patches on the NASA Dawn spacecraft surface were later identified as salt deposits that may have been left behind by evaporating water. A hybrid world that is neither quite a planet nor a conventional asteroid, Ceres provides insight into the precursors of planetary formation. Rust is what gives Mars its crimson appearance. Iron oxide, the same substance that gives rust its color, is present in fine particles on Mars's surface. This iron-rich substance has oxidized in the thin Martian atmosphere over billions of years, giving the planet its distinctive reddish color. The dust is so widespread that it covers the entire globe and tints the sky during storms. Although Mars appears rusty, its surface is subtly colored due to the presence of black polar ice caps and basaltic slopes. From a distance, however, the characteristic crimson tone predominates, a dusty indication of oxidation on a frigid desert planet. On the surface of the Sun, some places are cooler than others. Some parts of the Sun appear darker even though its surface is burning at thousands of degrees. They are cooler than their surroundings, not because they are frigid. These are sunspots, which are transient areas where strong magnetic activity prevents heat from escaping. Sunspots frequently occur in pairs or clusters and can be larger than Earth. They have an 11-year cycle and become increasingly active and abundant as the Sun gets closer to solar maximum. They are still thousands of degrees hot, despite their name, but the contrast gives them a gloomy appearance. The Sun's constantly shifting interior rivers are seen through these magnetic scars. By using a telescope, Uranus was found. In contrast to the planets that have been seen since antiquity, Uranus was not formally recognized until 1781, when astronomer William Herschel used a telescope to view it. He initially believed it to be a star or comet, but additional observations verified that it was moving in a planetary orbit. As the first planet to be found in the modern era, Uranus increased the solar system's known bounds. With its discovery, astronomy by the unaided eye gave way to exploration using instruments. From its high axial tilt to its faint rings and ice moons, Uranus has since shown numerous surprises. It is a planet that subtly altered the night sky's map. There are roughly 4 solar systems, 6 billion years old. Scientists have determined that the solar system is around 4.5 billion years old by examining radioactive isotopes, ancient meteorites, and the oldest rocks on Earth and the Moon. The Sun was formed at the core of a solar nebula, which started out as a swirling cloud of gas and dust that collapsed due to its own gravity. Comets, asteroids, moons, and planets formed from the leftover material. The groundwork for everything that came after was established by this accretion and differentiation process. The planets that exist now are remnants of a turbulent early history that was molded by long-term, slow cooling, migrations, and collisions. Vesta is structured like a planet with layers. Vesta is more than just a rock. It is the second largest object in the asteroid belt. This protoplanet has layers that are distinct. Like the interior structure of Earth and other terrestrial planets, it has a solid metallic core and a mantle under its surface. Accordingly, Vesta formerly possessed sufficient interior heat to melt and divide into layers, a process known as planetary differentiation. Some of these deeper layers may have been revealed by the massive impact that formed the Resilia crater at its south pole, a planetary construction block that never quite achieved full planethood. The rest is a frozen fossil. The Moon trembles. The Moon trembles sometimes, yet it seems to be motionless and quiet. These moonquakes may be brought on by meteorite strikes, thermal expansion as the lunar surface heats and cools, or tidal pressures from Earth's gravity. Compared to earthquakes on Earth, some of the Moon's deepest quakes can last up to an hour. These faint tremors were initially detected by data from the Apollo missions, and additional detectors are still examining them. Despite lacking tectonic plates, the Moon's tremors indicate that its interior is not completely inactive. A sturdy universe with a heart that beats quietly. Triton is a moon that has been taken. Triton, the largest moon of Neptune, is distinct from other major moons in that it rotates retrogradely, or in the opposite direction of the planet's rotation. This peculiar trajectory implies that Triton was long ago taken from the Kuiper belt rather than forming around Neptune. This captures gravitational disturbance might have tilted Triton's own interior, triggering tidal heating, and destroyed Neptune's initial moons. Today, Triton has a thin atmosphere, a frozen surface with odd cantaloupe-like textures, and geysers that shoot nitrogen into space. It is both a moon formed by a violent adoption and a remnant of the outer solar system. There are 14 known moons of Neptune, at least 14 moons, varying in size from big and enigmatic to tiny and erratic, circle Neptune, the primary planet that is furthest from the Sun. The majority of the mass is made up of the largest, Triton, while Proteus, Naiad, and Lissa all take unique and distinct routes. While some might have developed from collisions or debris, others are probably caught Kuiper belt objects. The majority of these moons reflect very little sunlight and are black and cold. Their orbits provide information about potential planetary migrations and Neptune's tumultuous past. Around a planet that floats on the other side of the solar system, they create a dispersed family of partners. The Sun is being touched by the Parker Solar Probe. The first spacecraft to go straight into the Sun's outer atmosphere was NASA's Parker Solar Probe, which was launched in 2018. Known as the Corona, it can withstand temperatures of over 1,000,000 degrees Celsius and travels at incredible speeds, faster than anything ever constructed. With each orbit, the probe, shielded by a carbon composite heat shield, gets closer to collect information on the solar wind, magnetic fields, and energetic particles. Its goal is to unravel long-standing riddles, such as how solar flares accelerate and why the Sun's corona is hotter than its surface. In a way, it is soaring through the Sun rather than merely watching it. Earth received some meteorites from Mars. Mars is millions of kilometers away, but fragments of it have reached Earth. These are Martian meteorites, which are rock fragments that were blasted from the surface by strong impacts. They traveled across space before landing in our atmosphere. By comparing their chemical composition to information gathered by Mars rovers and orbiters, scientists are able to identify them. Tiny bubbles of trapped Martian air and water-shaped crystals can be found in some of these meteorites, providing direct hints about the geological and chemical past of Mars. Long before any spacecraft did the same, nature delivered us these stray stones as samples from another world. Helium and hydrogen make up the majority of the Sun. Helium makes up the majority of the Sun's mass, with hydrogen accounting for about 70%. Its composition is dominated by these two lightest elements, which also power the nuclear fusion at its center. Massive amounts of energy are released when hydrogen atoms fuse into helium under intense heat and pressure. Oxygen, carbon, nitrogen, and heavier elements, all of which came from previous star generations, make up the remaining 1 to 2% of the Sun's mass. The Sun, a luminous orb of primordial gases formed by gravity and nuclear fire, is essentially simple in composition despite its brilliance and complexity. Seasons are a result of Earth's tilt. The tilt of the Earth's axis with respect to its orbit around the Sun is approximately 23.5 degrees. We have seasons because of this tilt. Summer is the result of one hemisphere being oriented toward the Sun, which gives it more direct sunshine and longer days. Winter arrives when the Sun is tilted away, resulting in shorter days and less sunlight. The seasons would hardly exist without this tilt. Additionally, the majority of Earth's climates would be far more consistent. The Moon's and other planets' gravitational pull has caused the tilt to somewhat change throughout time, but it is still one of the silent creators of life's seasonal cycles. The greatest structure in the solar system is Jupiter's magnetosphere. Millions of kilometers into space, Jupiter's powerful magnetic field creates a magnetosphere so enormous that if it were visible in the night sky, it would dwarf the Sun. Electric currents in the metallic hydrogen interior of the planet drive this field. Charged particles in the magnetosphere speed along magnetic lines, producing powerful electrical storms, enormous auroras, and strong radiation belts. The field molds the orbits of neighboring moons and collects particles from the volcanic eruptions of Io. This radiation poses a serious risk to spacecraft. It serves as a laboratory for researchers looking into the most extreme forms of planetary magnetism. Planetary rings could be transient. Planetary rings, such as those surrounding Saturn, Jupiter, Uranus, and Neptune, may be very short-lived on cosmic timescales, despite their seemingly eternal appearance. Broken moons, residual debris, or frozen particles drawn into orbit can all produce rings. However, gravity, magnetic pull, or collisions can cause these materials to spiral inward over millions of years, finally landing on the host planet. According to observations, Saturn's rings might not be more than 100 million years old, and they might disappear in another 100 million. It's possible that the rings we see now are a brief stage, a breathtakingly beautiful point in a planet's much longer life. In the absence of wind, rain, or active geology, the Moon's surface hardly changes over time. For millions or possibly billions of years, the Moon's surface doesn't alter much. Astronauts' footprints will probably be maintained for thousands of years. The primary causes of the progressive degradation of the lunar surface, known as space weathering, are cosmic radiation and micrometeorites. The landscape is still dominated by craters from ancient impacts, which have left a record of collisions dating back to the early days of the solar system. The Moon is one of Earth's oldest and most reliable geological archives, in addition to being its nearest neighbor. Hydrothermal vents may exist on some cold moons. Scientists think underground oceans may come into contact with hot, rocky cores beneath the frozen crusts of moons like Europa and Enceladus, creating hydrothermal vents that resemble those on the ocean floor of Earth. These vents use chemical energy from minerals and hot water to sustain vast ecosystems on our planet without the presence of sunshine. These moons may have similar vents, which might supply water, heat, life, and a consistent source of energy. Enceladus plumes even contain substances linked to biological functions. Perhaps the most intriguing locations for looking for extraterrestrial life are these secret underwater worlds. It takes more than 8 minutes for sunlight to reach Earth. The photons produced by nuclear fusion in the Sun's core are the source of the light that warms your skin and illuminates the sky. After that, these photons bounce and scatter through thick plasma as they make their way from the Sun's center to its surface over hundreds of thousands of years. But after leaving the surface, it takes them just over 8 minutes to cover the remaining 150 million kilometers to reach Earth. You get a peek of the very recent past when you witness a sunrise or the midday sun. You are not viewing it as it is, but rather as it was 8 minutes ago. The fractured ice on Europa might move like tectonic plates, a shell of ice crisscrossed with ridges, black lines, and disordered topography covers the surface of Jupiter's moon Europa. These characteristics imply that, like the tectonic plates of Earth, the ice may be shifting, shattering, sliding, and perhaps subducting. If this is accurate, Europa would be the only known body with active plate-like motion outside of Earth. The Moon's habitability may be improved by the process, which could aid in the cycling of nutrients between the ocean below and the surface. Jupiter's gravity, which constantly requires Europa's interior, is probably the driving force behind the tidal flexing. Although the world is frozen, it is not stagnant. Water is denser than Saturn. Saturn would float if it were submerged in a gigantic cosmic bathtub. Its average density is lower than that of water, not because it is hollow. Saturn is light in spite of its enormous size because it is primarily made of hydrogen and helium. Although its mass is only roughly 95 times bigger than Earth's, its volume is enormous, more than 700 times greater. Because of its low density, Saturn has a soft, diffuse structure that rotates quickly, flattening it at the poles and bulging it at the equator. It is a giant of gas that has been gently inflated into shape by motion and gravity. Earthly technology can be disrupted by solar flares. Frequently connected to sunspot activity, solar flares are abrupt, intense outbursts of energy from the Sun's surface. X-rays and ultraviolet light are among the powerful radiation bursts that are released during these outbursts. They can disrupt the upper atmosphere when pointed at Earth, which can have an impact on satellite operations, radio communications, and GPS systems. In severe situations, they may cause power grid damage by starting geomagnetic storms. Although Earth's magnetic field provides safety, Flares serve as a reminder that the Sun is a dynamic, volatile star that periodically pulses energy throughout the solar system, rather than being a constant light bulb. Auroras are influenced by the solar cycle. When charged solar particles come into contact with Earth's magnetic field and atmosphere, they produce auroras, which are the glistening curtains of green, red, and violet light that appear close to the poles. On an 11-year cycle, these displays increase in frequency and intensity during times of strong solar activity. Brighter auroras are fueled by more particles rushing toward Earth due to greater sunspot activity and solar flares during solar maximum. The lights are quieter when the Sun is at its lowest. The sky serves as a reminder that space weather has the ability to subtly paint the heavens with the Sun's magnetic variations as they radiate outward. The tails of comets are always pointing away from the Sun. A comet's icy surface sublimates as it gets closer to the Sun, releasing dust and gas that creates a luminous tail. However, the tail does not follow the comet like smoke does behind a train, despite what one may think. No matter which way the comet is traveling, it always points away from the Sun. This is due to the material being forced outward by the solar wind and radiation pressure, creating two separate tails, a straight bluish ion tail and a curving dust tail. The end effect is a bright windswept mark that follows the Sun's invisible force through space's gloom. Giant collisions created certain planetary moons. It is thought that more than 4 billion years ago, a massive impact between the early Earth and a Mars-like planet created the Moon. The material that was thrown into orbit by the collision eventually came together to form the Moon. The moon cairn of Pluto and other moons are thought to have similar impact origins. The captured moons of the outer planets contrast with these dramatic beginnings, demonstrating that no single process can account for all satellites. Some moons were created by mild gravitational snaring, whereas others were created by fire and collision. Their varied origins reflect the turmoil and inventiveness of the early solar system. A golden record is carried into deep space by Voyager 1. Voyager 1 was launched in 1977 and is currently the farthest distant human-made object in interstellar space. A golden record, a phonograph disc with sounds and pictures selected to symbolize life on Earth, is fastened on its side. It features greetings in dozens of languages, recordings of laughing, waves, and bird sounds, as well as music from around the globe. The record was created by a group under the direction of Carl Shawn and is intended for any sentient beings that may come across it in the future. It's a message sent out into the galaxy in a bottle. From our light blue dot, a silent greeting. Co-orbital asteroids and Earth share an orbit. Earth shares its general region of space with small bodies called co-orbital asteroids, despite the fact that it only orbits the Sun. These objects follow stable looping routes close to Earth's orbit that are influenced by gravitational interactions rather than orbiting the planet like moons do. Some, known as Trojans, circle stable landmarks in front of or behind Earth. Others take horseshoe-shaped routes that keep them close together without ever bumping into each other. Over thousands of years, these peaceful friends are frequently caught and released. They float close to us in space, invisible to the naked eye, fellow passengers on our annual orbit around the Sun. Prior to its official discovery in 1846, Neptune was mistaken for Uranus. It's possible that some early astronomers saw it without understanding what it was. At times it was mistaken for a fixed star or believed to be another sighting of Uranus because of how slowly it moved and how dim it seemed. In fact, it's possible that Galileo mistakenly identified Neptune as a star in 1612 after seeing it via his telescope. The existence of Neptune was neither predicted nor verified until mathematicians discovered anomalies in Uranus's orbit. For eons, Neptune stayed out of sight in a sky full of roving points of light. Gravity does not define the solar system's edge. Pluto is only a small part of the Sun's gravitational force, which also holds onto far-off comets and frozen objects in the Oort cloud. However, the boundary of the heliosphere, which is the area where the solar wind and interstellar medium meet, is frequently referred to by scientists when they discuss the edge of the solar system. This edge, known as the heliopause, denotes the boundary between particle flow and the Sun's magnetic field's impact. The distance between stars starts at the energy boundary, although gravity extends much beyond. More a movement in pressure than presence, it's a subtle moving frontier. The atmospheres of planets gradually seep into space. Earth and other planets with dense atmospheres are not permanent. Light gases, such as helium and hydrogen, have the ability to drift into space over time after escaping a planet's gravity. On smaller planets with less gravity, like Mars and Mercury, this process, known as atmospheric escape, is more noticeable. Parts of Venus's upper atmosphere have been eroded by the solar wind due to a lack of magnetic shielding. Every year, thousands of tons of hydrogen are lost from the Earth. The gradual departure of gases is a silent leak into the emptiness, a continuous trade between planets and the vacuum outside, even though it is readily restored. It's possible that certain moons originated from ring systems. Ring systems can produce moons, just as they can eventually decompose into planets or disappear. Beyond the planet's Roche limit, which is the point at which gravity can attract materials into moons rather than split them apart, some of Saturn's small outer moons may have formed from ring material that clumped together. It's possible that debris from Saturn's rings is still being accreted by moons that orbit inside its rings, such as Pan and Daphne's. Their gravitational pull creates waves and fissures in the surrounding icy bands, making these moonlets silent sculptors of the rings. Data from interstellar space is still being sent by Voyager 1. Even though Voyager 1 is billions of kilometers away from Earth and traveling through the interstellar medium, it is still sending back feeble signals to the planet more than 45 years after it was launched. Its instruments monitor plasma density in the interstellar medium, magnetic fields, and cosmic rays. Despite low power and the steady shutdown of systems to save energy, the spaceship continues to operate. It communicates through the deep space network and is powered by a small nuclear source. A whisper from the brink of human exploration, each signal takes almost 20 hours to reach Earth. Every 225 million years, the solar system completes a galactic orbit. The Sun itself is in motion, circling around the Milky Way galaxy's center while the planets orbit it. One orbit, commonly referred to as a cosmic year, takes about 225 to 250 million years to complete. The solar system travels through many interstellar space areas over that time, possibly going through star-forming regions, galactic arms, and gas and dust clouds. Comet activity and, on a longer time scale, the temperature of Earth may be impacted by this motion. As we travel around the arm of the galaxy like a cosmic carousel, we are not stationary in space, but rather a part of a massive, slow spiral. Thus, our peaceful voyage across the solar system gently comes to an end. One slumbering fact at a time, we have journeyed together through orbits, storms, and shadows, from the inner world charred by sunshine to the cold moons that murmur in the dark. It's okay if your eyes are already heavy. Let your breath gently lead you to sleep as the last vestiges of starlight disappear behind your thoughts. You've learned enough for now, but there's still a lot more to learn. The cosmos can wait until dawn since you've come a long way. I appreciate you taking the time to speak with me. So the story goes on beneath the silent stars. I wish you a restful night's sleep and peaceful dreams. Good night.